A manufacturing team discovers that a critical dimension on a part is failing inspection. The quality inspector measures the part and gets 20.05 millimeters. The production supervisor checks the same part and gets 20.01 millimeters. An engineer measures it again and gets 19.98 millimeters. Same part, same day. 3 different answers. Now the team has a problem. Is the part actually bad? Is the machine creating variation? Did the supplier send inconsistent material? Or is it something else happening here? Because before you can start adjusting machines, rejecting the parts, or launching corrective action, there is one question that experienced engineers ask first. Can we trust the measurement telling us there is a problem? Welcome to Engineering Explained Simply, where we uncover why engineering decisions succeed or fail. On this channel, we go beyond explaining tools and standards. We explore how experienced engineers think, how they investigate problems, and how technical decisions connect to real business outcomes. If you work in manufacturing, engineering, quality, or you're building your engineering foundation, consider subscribing because every video focuses on practical engineering thinking beyond textbook definitions. Manufacturing decisions are built on measurements. Think about how many decisions depend on numbers. Can we release this product? Is the supplier process stable? Did our corrective action actually work? Is our process capable? Should we invest in improving this machine? All of these decisions depend on one assumption. The data we are using is trustworthy. But here's the problem. We often question the process, the machine, the operator, even the supplier, but we rarely question the measurement system itself. And if the measurement system is unreliable, we can make very confident decisions based on incorrect information. Let's go back to our example. The team starts investigating. First question, did the manufacturing process change? Maybe. They check machine settings, everything looks normal. Second question, did the supplier change something? They review the material history. No obvious issues. Third question, did the operator make a mistake? Training records look good. So what is left? The measurement system, the tool being used to make the decision. This is where many organizations miss something important. A measurement is not just a number. A measurement is a process, and that process has variation too. This is where Gage R&R comes in. Gage R&R stands for Gauge Repeatability and Reproducibility. It is a part of Measurement System Analysis, commonly called MSA. The purpose is simple: to understand how much variation comes from the measurement system itself. In other words, before we use measurements to judge a process, we need to know whether the measurement system is giving us reliable information. Gage R&R looks at 2 main sources of variation: repeatability and reproducibility. Let's start with repeatability. Repeatability asks, if the same person measures the same part multiple times using the same equipment, do they get consistent results? Imagine an operator measuring the same diameter 5 times. The results are that measurement system is showing good repeatability. The operator is getting almost the same answer each time. Now imagine this. Now we can see we have a problem. The part did not change 5 times. The measurement process created the variation. Maybe the gauge has issues, maybe the operator is applying different measurement pressure, maybe the part is not positioned consistently. The important question is, can we trust these results? Now, let's look at reproducibility. Reproducibility asks, if different people measure the same part, do they get same answer? Imagine 3 inspectors measuring the same component. Inspector A gets 20.01 millimeter. Inspector B measures the same part 20.05 millimeter. And Inspector C measures the same part at 19.98 millimeter. The disagreement tells us something important. The problem may not be the part. The problem may be how people are measuring the part. Maybe different techniques, different setups, different interpretations. A measurement system must produce consistent results regardless of who performs the measurement. Now, let's step back. Gage R&R is not really about gauges. It is about decision confidence. Imagine a company making decisions based on unreliable measurements. They may reject good parts, accept bad parts, spend money fixing a process that was never broken, maybe even blame suppliers unnecessarily, delay production, or worse, ship products believing everything is under control. The cost of poor measurement is not just a quality issue, it becomes a business issue. There is also a human side to this problem. People naturally trust numbers. A spreadsheet looks professional. A graph looks convincing. A report with data feels objective. But experienced engineers know something important. Numbers are only good as the system that created them. A perfect analysis using unreliable data can still lead to wrong decisions. This is why good engineers do not blindly trust data. They understand where the data comes from. So when should you think about Gage R&R? Before making important decisions based on measurement data, especially when you are studying a new measurements method, you are approving a new supplier, you are validating a process, you are investigating unexpected variation, or you're making a decision where measurement accuracy matters. The question is not, do we have measurements? The better question is, can we trust the measurements we have? A process cannot be approved using data you cannot trust. Before you fix the process, make sure you can trust what the process is telling you. I would love to hear from you. Have you ever experienced a situation where different people measured same thing and got different results? Share your experience in the comment section. And if you want to keep learning the hidden reasons behind engineering decisions, subscribe to Engineering Explained Simply. In the future videos, we will continue exploring why process fails, why corrective actions don't last, and how experienced engineers approach difficult problems. Thank you for watching.